Hi guys, alright, welcome back. Let's continue with shapes and patterns. Drawing shapes from model figure patterns. Guys, it's kind of like tracing someone or tracing something onto a board or a piece of paper or anything like that. I'm trying to see something. Hang on. Okay, so it's kind of having to trace something. Look at this. What shape is it? Right? What shape do we think it is? Now, looking at it like this, you guys are seeing just the one dimension. You're seeing the front, right? Or you're seeing a two dimension. But the moment you can see the front, the top, and the side, then you're seeing three dimensions, right? 1, 2, 3. You're seeing three sides. So we're going to take this three-dimensional shape, right? This model, this figure. Taking our marker and now being able to put it on there and trace, right? All right, how does that look? Yeah, there we go. All right, being able to trace objects onto a piece of paper or onto a board, and that turns out to be a perfect quadrilateral. 1, 2, 3, 4. 4 corners. 1, 2, 3, 4 sides. All right, quadrilateral. Now, taking this, for example, in 3D, that's called a cylinder, right? But when you trace the bottom of a cylinder onto a piece of paper, it's a circle, right? This, because it's a 3D model, right? It will be called a cuboid. But because you're tracing it onto a two-dimensional surface, it's becoming a quadrilateral, all right? Right, and this one, for example, all right, you have a model of an ellipse, right? But when you trace it, it becomes an oval, right? It becomes an oval. So when it's a model like this, where you can see three dimensions of it, it's called an ellipse. But the moment we copy it onto the paper, it becomes an oval, all right? Okay, what do we have here? Okay, three-dimensional geometric shapes, guys. 3D shapes. All right. Now, I'm not an artist. You guys have seen me draw faces. It's horrible. But let's look at something. I'm gonna do this nice for you guys. Alright, what is that? A quadrilateral, yes? Or just a square, right? It's a normal square. You're only seeing one dimension. You're only seeing a flat picture of it. But let's change that. Look at this. Check this out. Oopsie. Now, it's not just a square anymore. It's changed, it's become a cube. It's now become a cube. Why? Because it's got 3 dimensions. You can see the front. That's the front. Right, I'm looking at it. This is the top. Right? I'm seeing the top view. And this is looking in from the side. Right? So, you can see 3 dimensions. 1, 2, 3. Now, you've heard the word cuboid. Let's look at what a cuboid is. Alright. A cuboid, guys, as you see that, it's a normal rectangle, right? It's a normal rectangle, it's a normal quadrilateral. You're seeing one side of it, easy peasy. Let's change that. Okay. Now it's different. Now it's no more just a rectangle, or it's no more just a quadrilateral. Now it's changing to a cuboid. A 3-dimensional image of a rectangle. Alright, it's become a cuboid. Alright, rectangle, cuboid, and a normal square becomes a cube. Alright, guys, front, it's one side. Top, it's 2 sides. And I can see the side as well. That's 3 sides, 3D, 3-dimensional. This can be changed into more by adding little, I wonder if I can remember how to do it. Hang on, let's see. Wonder if I can remember. Right? By adding that, this is now the bottom. Right? That represents the bottom. That represents the other side. Right? And that is now the back. Alright? Still a cuboid. Okay? Alright, guys. A cuboid is a 3-dimensional geometric shape obtained by stacking equal quadrilaterals one on top of the other. Alright? For example, 1, 2, 3. You can see 3 sides. Right? 1, 2, 3. You can see 3 sides. 1, 2, 3. You can see 3 sides. Rectangle, square, cube, becomes a 3-dimensional, becomes cuboids. Alright? Alright, a cylinder. A cylinder is a 3-dimensional geometric shape obtained by stacking equal circles one on top of the other. This is almost a cylinder, right? Yeah. It can be, especially if you cut off this piece. This is a cylinder, right? Because if I trace this, it's a circle. All of these are circles. So this is a cylinder now. Especially if I show you like this. Because then you can see that side, you guys can see this side, and you can see the bottom, right? It becomes a cylinder. Right? Actually, hang on. The picture they show us here. You can see the top, you can see the bottom, and you can see the front. That's 3-dimensional, right? It becomes a cylinder. Alright, a sphere. Guys, a sphere is a three-dimensional geometric shape obtained by rotating a circle. Alright? So that's basically, if you take a coin, you guys take a 10 baht coin, right? You put it on the table, you put your finger on top and you flick it, it goes, yeah, it turns like this, like crazy. You can see all the sides, right? And that's kind of a sphere, alright? That's what we call a sphere. So even if I was good and I played basketball or football, and I take the ball, I take the soccer ball, and I put it on my finger and I spin it. You guys have seen how the ball spins and spins on the finger, and you go, it's a sphere, alright? Because you can see all the sides of it. Alright, identify the three-dimensional shapes of the objects. Not going to do it right now with you. When we review the work, we're going to look at it, okay? Same with this, we will review it later. What else are we doing? Drawing shape, okay. Okay, guys, the next thing, it's about being able to identify two-dimensional from three-dimensional geometric shapes. Differentiating between quadrilaterals and cuboids. As we have seen before, a cuboid is a three-dimensional geometric shape obtained by stacking equal quadrilaterals one upon the other. The difference between a quadrilateral and a cuboid can be understood by a simple example of a book. Alright? Okay. The shape of the paper is a quadrilateral. Many such papers are put together to make the book. The shape of the book is a cuboid. Guys, again, it's so easy. Alright? They're showing us one single piece of paper. Alright, I don't want to damage the book. A single piece of paper, just a single piece of paper. If you trace it onto a board like I've shown you, it's a normal quadrilateral, 1, 2, 3, 4 corners. The moment you can start seeing three dimensions, like I say, a lot of paper stacked on top of each other, now you guys can start seeing more. You can see the front, you can see the top, you can see the side. Alright, now it becomes a cuboid. Okay? Differentiating circles from spheres. Alright, as we have seen before, a sphere is a three-dimensional geometric shape obtained by rotating a circle. Like I told you, the ball on the finger. You spin it. Alright? Or a coin. You flick it and it turns on the table. The difference between a circle and a sphere can be understood by a simple example of an orange slice. Alright. That's one slice, normal. This, now they've cut it in half still, it's still cut in half. They put something through and then they spin it. And if they spin it really, really, really fast, you can't even see that it's cut in half. Three-dimensional. Alright. The shape of an orange sliced in half is a circle. Okay, that's a circle. When the orange is rotated fast, it looks like a full orange. The shape of the full orange is a sphere. Alright. When they rotate it very, very, very fast, you guys can see. Yeah. Hopefully when you come back I can show you guys how cool that is. Alright. Alright guys, these are just being able to identify the objects, which are quadrilaterals, which are cuboids. Not going to do it right now, we're going to do it when we review the work. Alright? Alright guys, that's it for now. Next video lesson, we're going to start looking at what this is. Alright, goodbye. Bye. Bye.